Welcome to this update of the ZKPerp demo. ZKPerp is the first privacy-preserving perpetual decentralized exchange on Aleo. This is an update for Wave 3 of the buildathon. In an earlier demo for Wave 2, we already demonstrated how ZKPerp works. We showed how liquidity can be added and how users can open and close leveraged positions. In this demo, we will discuss the updates made in Wave 3. In Wave 3, we deployed the new smart contract as perp_v12 on the public testnet. This update introduces three major improvements. The first improvement is the introduction of a slot-based record model, which significantly enhances the user experience. Trading positions remain private, but users can decrypt their own private records on-chain. Previously, if a user executed 10 trades, they would need to approve all 10 records in their Shield wallet. Our solution introduces a slot-based system with 3 fixed slots, one for the LP position, one for a long position, and one for a short position. As a result, users only need to decrypt 3 slots in their wallet. This effectively eliminates record accumulation. The second major improvement is the liquidator bot. In Wave 2, position liquidation was performed manually by calling a function through the frontend. In Wave 3, liquidations are fully automated. We deployed a server running a liquidator bot that continuously reads all open positions using provable record scanning. The final improvement is the integration of a real price oracle. The liquidator bot needs to monitor the price of Bitcoin to determine when positions should be liquidated. Since oracles such as Chainlink do not yet support Aleo, we use the Binance price feed for this demo. When a user connects their wallet for the first time, the account needs to be initialized. ZKPerp uses fixed slots to keep the wallet clean. No matter how many trades a user makes, there will always be only 3 slots. The system uses 2 trading slots and 1 LP slot. Each slot is reused for every trade, the previous record is consumed and a new one is issued. Let's initialize this new wallet. We will start with adding liquidity again. First we need to approve USDCX on Aleo. Here we can see that there is 1 slot for the LP in this wallet. Now let's add liquidity for the first time. Here, we see that there is 1 LP slot in this wallet. We add 500 USDC. Now we will add liquidity for the second time. We decrypt the LP slot to reveal the private information. Here we can see that the LP slot already contains 500 USDC. Now we add another 50 USDC. Now we can see that we still have only 1 LP slot, which now contains 550 USDC. Positions also use fixed slots. We use 1 slot for a long position and 1 slot for a short position. Now let's open a long position. Here we can see that there are two position slots. Let's decrypt them. Now we can see that one slot is filled with the open long position. Now let us take a look at the liquidate page. Here we can see that an oracle and a liquidation bot are running. These bots run on a server. Here we can see the current price of Bitcoin. We can also see that the bot is monitoring one currently open position. If we open the orchestrator dashboard, we can see the details of this position. Positions are private, and only the trader and the liquidation bot can see the details. We use a dual record architecture. When a trader opens a position, they receive a position slot. At the same time, the orchestrator receives a liquidation auth record. This private record allows the liquidation bot to monitor all positions. As we can see, this position is still healthy and not in danger of liquidation. Now let's close this position. Now we will demonstrate a liquidation. We temporarily turn off the bot so that we can override the Bitcoin price. We then increase the price of Bitcoin to $200,000. Now we open a new long position. Note that the entry price is now $200K. Let's find the position. Note that we still have the same two fixed slots. Here we see the current position. The current price of Bitcoin of 200,000. Now we restart the oracle and the liquidation bot. In reality, the price of Bitcoin is much lower than $200,000, so we expect the bot to update the price. Here we also scan the positions. As we can see, the bot is now monitoring these positions. Please note that the server is still starting up and has not updated the price of Bitcoin yet. Here we can see the logs of the liquidation bot. Price has been updated. The bot uses provable record scanning and has found a position that can be liquidated. Here we can see that the liquidation has been initiated. And it worked. The liquidator bot liquidated the position successfully. That concludes the Wave 3 update of ZKPerp. In this release, we introduced three major improvements. The first improvement is the slot-based record model, which significantly enhances the user experience. Our system uses three fixed slots, one for the LP position, one for a long position, and one for a short position. As a result, users only need to decrypt 3 slots in their wallet, eliminating record accumulation. The second improvement is the liquidation bot. Liquidations are now fully automated. We deployed a server running an oracle and a liquidation bot that continuously scans all open positions using provable record scanning. The third improvement is the integration of a real price oracle. Together, these improvements make ZKPerp more scalable, automated, and user-friendly for private perpetual trading on Aleo. Thank you for watching, and stay tuned for more updates in Wave 4 and beyond.